So now we've arrived at arguably the most important part of chemistry, namely balancing equations. If you can't properly balance an equation, it's going to be really hard for you to do a lot of things in the second semester. So I figured I'd record a couple of these, kind of take you through the process, kind of give you a few tips that have helped me over the years, and hopefully this will help you get started with balancing equations. Now, eventually, you're going to have to be able to essentially get a balanced equation from scratch. That is, you're going to have to write out formulas based on word equations and basically get them from scratch. If you still are unfamiliar with the process of writing a chemical formula, we're going to have plenty of practice with that. But I figured just to get the basic concept of balancing equations down, I'd give you the formulas. Now, up on the right side of the screen, you see sort of the four steps and one set of tips that I gave you on balancing equations. Now, the first step is always to get the correct formulas for elements or compounds if you need to. Now, in this case, obviously, we have those formulas, so we can skip that step. And sometimes we won't need to get those formulas. Now, number 2 is to arrange the reactants on the left and the products on the right. That should be review from just about every science class you've ever taken, so I don't think I really need to hit that one too hard. Now, the whole trick of balancing equations is basically a math problem. So what I'd like you to do is to make a grid, and that grid will help you keep track of the atoms of each element on each side of the equation. So what I like to do, and this is something that my old chemistry teacher taught me way back in the day, is I make a really simple chart. If you can make something into a chart, it's always a good idea to organize your thoughts. So what I do is I put along this left-hand side here, I just write down all of the atoms that I have in this compound. So I have aluminum, I have chlorine, and then I have sodium. So real simple, just 3 different atoms that we're dealing with. Now in that grid, I'm going to fill in, based on what I see in front of me right now, the number of atoms of each element. So to do this, we need to count both the coefficients and the subscripts. Remember, coefficients are big numbers in front, subscripts are small numbers to the side, like this 3 right here. So what we're going to do is just count the atoms. So here we have no subscript in front of aluminum on the left, so we have 1 aluminum on the left. We have no subscript on the right, so we also have 1 on the right. When it comes to chlorine, we do have that subscript of 3, so we need to make sure that we have 3 chlorine atoms on the left, and we have just 1 on the right because, again, no subscript. So already we can see that we're going to have to do something about chlorine when all is said and done. And finally, we have sodium, 1 on the left, 1 on the right. No subscript in front of either one, so that's pretty much straight up. Now, like I said, the whole goal of balancing equations is to make sure you have the same number of atoms on the left and right sides of the equation. So, to do that, we can never, ever change the formula of the substance. So, for instance, if I wanted to take NaCl and make it fit, because we have 3 chlorine atoms on the left, I would be tempted, because, well, I don't want to figure out the real formula, to just put a 3 on NaCl and call it NaCl3. Obviously, that's not right. We know that sodium chloride is NaCl. If we needed to confirm that, we could always check the charges. But under no circumstances will you ever get NaCl3. It's not a real formula, so we can't use it. The only way you can change one of these substances is to add a coefficient, a big number in front. Now, something that often helps students remember that is to actually draw a line in front of each of the formulas. You see that up above in the equation. So, when you draw those lines, all you have to do is fill in the number. Now, if that number's 1, obviously, you don't need to fill in anything, because we assume right now that each one has a coefficient of 1. But if there's something other than 1, that's when you need to add a coefficient. So, let's go through step number 4 and see if we can add some coefficients. I'm going to stay with the red pen here because I like it. So, here we have one aluminum atom on both sides. So I'm going to go ahead and say that we're good there. I don't think we need to do anything about that. Now, chlorine, obviously, we have an imbalance, so we need to change something. Now, we have 3 on the left, and so on the right side, we need to make sure that we add a coefficient that gives us 3 chlorine atoms. And since each formula unit of NaCl has just 1 chlorine atom, we need to put a 3 in front of sodium chloride. That will give us 3 chlorine atoms. Now, the other thing that you need to remember is that that also changes anything else that's in that compound. So in this case, we also need to change sodium, even if that causes an imbalance, because we can't fake the fact that this coefficient counts for everything in that compound. So whatever is in this compound, we'd have to multiply by 3. Now, clearly, we have an imbalance now in the sodium atoms. So what we need to do is we need to correct that. Now, here, we have 3 on the right, so we need to make sure that we do something about the left side. Fortunately, since that's an element, it's really easy to do. We add a 3 in front. We now have 3 sodium atoms. We now have a balanced chemical equation. Now, I just wanted to highlight a few tips and special cases, this part over here. Now, when we get to them, you're going to deal with polyatomic ions. Now, eventually you're going to commit these to memory, and you're going to recognize that, for instance, NO3 is a nitrate ion. Now, if you see that on both sides, treat it as a unit. There's no reason that you can't do that because it's the same on both sides. So that'll help you rather than having to keep track of individual oxygen atoms or nitrogen atoms. You can just keep track of nitrate ions, for instance. Now, generally, and we actually did this here, we ended up doing this, you should deal with 3 things last. So deal with everything else first. The 3 things you should always deal with last are individual elements, like sodium, that we did here, hydrogen, and oxygen. Now, the reason we deal with individual elements last is because they're the easiest to fix, because when you do add a coefficient, you don't change anything else. Here, in the case of sodium, we just change sodium. So, that's pretty easy. Now, we have sort of an opposite reason for dealing with hydrogen and oxygen last, because hydrogen and oxygen tend to appear in a lot of different compounds. So, as a result, we need to be really careful when we deal with those 2 elements. So that's about it from here. Stay tuned for more podcasts, and thanks a lot.